the islands of Bermuda, shipwreck capital of the world, home to more than 300 known wrecks. Countless others lay undiscovered beneath the shifting sands. Its dangerous ring of reefs ended so many voyages across the Atlantic. Early sailors called it the Devil's Isle.
All these people saw Bermuda as this awful place to avoid because you couldn't navigate near it. Pretty much every breaker has a shipwreck next to it, or some piece of a shipwreck, because that's the areas that most shipwrecks first encountered Bermuda and essentially came to their tragic ends.
Once laid to rest on the seafloor, these wrecks were reborn as new habitats for life on the reef. Now, coral and fish communities thrive here, including the iconic parrotfish. This nationally protected species grazes algae off the reef, fostering new coral growth and contributing to the distinctive composition of Bermuda's sand.
All of the beaches in Bermuda are of coral in origin, so those beautiful pink sandy beaches, that all comes from corals.
All our sand is a byproduct of life. This whole island, this whole space, the part that we live on, is life itself.
Bermuda is made up of coral reefs, so if you look at the Bermuda platform, we're standing on coral reef structure here now.
Covering 280 square miles, Bermuda's extensive reef platform is essential for its tourism and fishing industries. More crucially, these reefs that once terrified mariners of old are now paramount to Bermuda's safety. They are all that protects the islands from the open ocean.
The role of coral reefs as a coastal barrier is huge. In Bermuda, it's been estimated that the corals on the South Shore, for example, dissipate up to 85% of the waves that are generated from storms or hurricanes. 85%, that's a lot.
If that reef system goes away, if those breakers go away, we're going to have high seas, highly dynamic ocean ecosystem bashing onto what is essentially a sand limestone island. That is literally what keeps us from disappearing.
Today, the reef and its shipwrecks are subject to the accelerating impacts of a changing climate. But Bermuda is in a unique position to meet those challenges.
Bermuda is really remarkable in that it's kind of a hope spot. Our corals are slightly more resilient, in part because they've done a really good job of managing them. They protect the parrotfish. And so there's a lot of thought put into how to take care of reefs and restoration efforts.
Gathered together in this tiny tropical haven, local Bermudians and international scientists strive to better understand and protect the islands and reefs they call home. How is climate change amplifying the impact of the open ocean on this small island nation? And what can we learn about resilience from the life that thrives at ocean's edge? With more than 60,000 residents inhabiting a mere 20 square miles of connected islands, Bermuda is one of the most densely populated countries in the world. In the bustling capital of Hamilton, it's easy to forget that this British territory sits atop an extinct mid-ocean volcanic seamount.
We actually live on the tip of one of the tallest mountains on the planet, on this little tiny pinpoint in the middle of the Atlantic. Originally, it would have been, they reckon, about 1,000 meters above sea level, and over time, the sea level up and down, and the weather just eroding it down. Now we're at the sort of, what you see is Bermuda.
Bermuda is in the middle of the high seas. This is an ocean volcanic pinnacle that is literally 750 miles from any continent. And it is the wilderness, right? It's an ocean wilderness. This is a high seas isolated island. And it's thousands of feet deep, literally 2 kilometers from the coast.
It is this precise location on the edge of the deep that makes Bermuda an ideal place to study our changing climate's impact on the ocean.
Bermuda is unique in that it's really easy to get to the open ocean from here. We can get consistent data of an ecosystem that's usually really hard to get to. So you can study these processes that typically are really hard to study.
Since 1988, researchers from the Bermuda Institute of Ocean Sciences, now part of Arizona State University, have diligently measured the ocean's physical, biological, and chemical properties. These standardized measurements, taken every month in the same location, are known as the Bermuda Atlantic Time Series Study.
We've got, back to the 80s, the ability to look at these trends, and that's the one where we've really started to get, the heartbeat of the ocean, what's going on, and how is that shifting with climate change.
This unique, long-ranging data set plays a critical role in climate change reports issued by the United Nations.
So when they're looking at trying to make predictions about, okay, what should we expect in 10 years if we make good choices? What should we expect in 10 years if we don't make good choices? Is they're looking at the trends that we have right now, and then they use that to project forward.
While this data helps provide an objective understanding of changing seas globally, the lived experience of observant Bermudians is equally as important when assessing local impacts and response.
Being from a place means you know a place. You love the place, right? So the level of attention you pay to it is also of another quality. It's not somewhere else, it's here, it's home. I think that's the really important scientific component that is easy to kind of not know about Bermuda or to not understand necessarily.
So, I've seen it in my lifetime change in the fact that the dock over here, we're traditionally now getting more and more tides that come up over the dock. You've got houses at sea level here that in a few years we expect them to be underwater. So it's not just about, the environment and the environment's changing, it's about how it's going to affect us.
While sea level rise is considered a gradual threat globally, islanders are acutely aware of the dangers posed by increasing nuisance events like storm surges and extreme high tides, or king tides.
Rising seas aren't just about averages, they're about extents. It's very important for us to get down to the local level because the averages may mask substantive changes at a local level that come far, far sooner than you might anticipate from what we project out forward into the future with the averages. And so long before your average tidal change is driving the kind of adaptation or the kind of problems that we need to adapt to, your nuisance events are achieving the same thing. If it happened every year, that's one thing. If it happens every week, then you're dealing with change that's happening now.
Bermudians are also witnessing an acceleration of the ocean's natural and ongoing reshaping of the islands.
There are certain areas where you can see the erosion happening quicker and quicker. We're made up of a majority of limestone. As the oceans get more acidic, we're going to dissolve faster. So worse storms, more acidic ocean. It's just not good news for us.
One of these places is Charles Island, where signs of rapid change are alarmingly evident. With each passing storm, more land is lost as the center of the island collapses into the sea.
So this is Charles Island, and as a kid I always remember this being sort of one sort of silhouette of the island going across. And as time's gone on and storms are becoming more and more frequent and even stronger, it won't be long before this ends up being 2 islands. So I would reckon by the end of next hurricane season or the year after, this will end up being 2 islands. I mean, the last big storms we had, you could see waves washing right up over the top. And obviously you've got soft limestone with pounding seas. It just doesn't have a chance.
These storms not only erode fragile shoreline, but also shift significant loads of sand around the reef platform. Imagery from NASA's Landsat satellite shows the extent of sediment movement following Hurricane Gonzalo in 2014. Sand was dispersed up to 30 kilometers from the island.
We're very used to in Bermuda that sort of dynamic ocean environment affecting our beaches, especially on the South Shore. And there's a lot of sand movement, but the big dramatic shifts where you're like, wow, 15 foot of sand has gone from this beach. In my childhood to young adulthood, I probably saw it twice. And I'll say that in the last 15 years, I've probably seen it about 6 times.
As Bermuda's custodian of historic shipwrecks, Dr. Philippe Rouja collaborates with local divers to monitor the integrity of the island's underwater cultural heritage. Shifting sands have been known to reveal historical artifacts and uncover hidden wrecks.
And I've been at the job now for 17 years, and in the first 7 years, I was certainly surveying shipwrecks after storms and hurricanes. But I'd say in the last 5 years, we've just had this consistent ramping up of these kind of weather events that are reaching deeper into our reef areas and actually impacting these shipwrecks at a higher rate than before.
One of these wrecks is a rare American Civil War blockade runner, the Marie Celestia, which sank in 1864.
About 12, 15 years ago, we started seeing that sand go, and enough of it went during Hurricane Fabian and other storms. That part of the stern that you only saw for 3 days after a storm is now visible all the time. So that says to us is that sand is not returned. What does this shift mean? It's not just a shift anymore, is it moving out to sea?
This immense ocean energy, capable of moving football fields of sand overnight, may suggest deeper impacts.
There's a difference between the whitewash that people think is the force of the ocean and the true force of the ocean, which is the swell. That big, deep ocean swell, the way it moves in and cruises over the reef platform, and that's broken up on our outer edge. And it's only speculation, but we're kind of feeling like the energy of that blue water is reaching deeper and deeper into the platform.
The direct impact of these swells can be seen today on the wreck of the Montana, Bermuda's only other Civil War blockade runner. As Hurricane Humberto swept across Bermuda in 2019, deep wave action decimated the bow of this beloved dive site.
This is a very iconic shipwreck that we're all quite attached to, and we have very fond memories of diving. There was a very attractive and very kind of iconic bow section to the Montana that we used to be able to go into and swim around and come back out. And now there's a whole aspect of the ship which is gone. It literally got blasted to smithereens. It was as if it was made of china, and the thing just got pounded. And all the corals that were attached, there was a beautiful field of coral growing across the side of the bow. And it was just literally broken into little pieces. And we just had this coral that just sort of went through a blender.
Examining the exposed forepeak of the shattered bow also revealed archaeological artifacts that would require protection. However, concern for the scattered corals was also a priority.
You know, the first thing was, oh my God, the shipwreck is damaged. And the next thought was, well, let's rescue the corals. It was sort of one and the same. It wasn't like I had to think about it. And me and many other divers, I think this is the way the diving community in Bermuda reacts to this. So it's not about caring for just this one part. It's all interwoven. They are inseparable.
Fortunately, Philippe had worked just a few years prior with the Cultural Heritage Engineering Initiative at the University of California, San Diego, to document the bow in extremely high resolution.
This thing is lost in its sort of physical aspect, but we have literally preserved it to the highest degree that we possibly could in this digital sort of matrix, so to speak. But in this case, what's great about it is it allows us to also document the process of the corals being moved. We now have a baseline from which you can measure any new coral growth that happens on that shipwreck. And so the shipwreck becomes a focus for science that we couldn't do before. All that can be compared and contrasted and scientifically analyzed and assessed going forward.
Today, Philippe and the diving community continue to monitor the Montana and the dislocated corals. But the unexpected destruction of this cherished cultural site has raised more profound concerns about the future impacts to the reef and the wrecks resting upon it.
What happened to the Montana with that sort of blue water reaching in and creating that damage, only blue water could do that to that wreck, only that level of energy. Well, what does that say about the larger forces at play? You can have a 12-foot swell out in the high seas ocean and on the inside of the shallow bar, and you're having a flat, calm day. That's what the reef gives us, right? And if that changes, that's a dramatic shift. That's a big change.
As home to one of the highest latitude reefs in the world, Bermuda is fortunate. Its unique location has kept its corals relatively healthy in the face of rising ocean temperatures.
I think we do have the really tough corals here because the corals here, they need to be able to overcome the seasonal changes as well. Like they naturally experience a really large range of temperature. Only species that are really tough are actually able to thrive in an environment like Bermuda.
Because we get this wide temperature range, we get gradients in these environmental parameters across our reef platform. So this gives us a natural laboratory.
Back at the Bermuda Institute of Ocean Sciences, coral ecologists are conducting a multi-year experiment to better understand the unique resilience of Bermuda's corals.
Resilience basically means whether or not you can absorb a certain stress or disturbance. It's how resistant are you against a stressor. So it's either like the coral is not really reacting to the stressor, or it's reacting but it's bouncing back really quickly and easily.
The idea there is what doesn't kill you makes you stronger. So if a coral goes through a thermal stress event, is it more likely to be more tolerant to that stress event in the future? We want to know which of these corals are going to be the winners. And once we finish these thermal stress experiments, we're going to be putting the remaining coral pieces back on the reef, and we're going to assess them over a year. We're going to bring them back in again next summer, and we're going to run another thermal stress experiment. So the idea is to see that the stress of our simulated bleaching event last summer, has that allowed a legacy or a memory of that thermal stress, in order that if we do it again to them the following summer, that they are more resilient to that.
Researchers also want to know if this learned heat stress resilience can be passed down through generations of corals.
So one aspect of the research is we are looking at epigenetics. So we want to see if coral stress tolerance is passed on to the juveniles. If we stress an adult coral, does that make its larvae and the subsequent juveniles more tolerant to future stress events as well? And how long is that memory of that stress? Does it last for a few months? Does it last for a year? Does it last for longer?
Working in parallel with ecologists, aquaculturists like Dr. Samia Sarkis are applying increased coral resistance to restoration, repairing reefs damaged by stressors like storms and hurricanes, and even modern shipwrecks.
Corals in Bermuda are impacted a lot by human activity. So, for example, if you have a vessel grounding, there's no reason why we shouldn't go back and restore that coral reef.
After a Norwegian cruise line ship veered off Bermuda's North Channel in 2015 and cut this 100-foot gouge in the reef, Samia joined government officials in surveying the damage.
We have the resources to be able to act, and at least we have to have the ability to respond to it and to help mitigate. We have to actually make sure that we have in place a system to be able to preserve the corals that we have.
In 2014, Samia founded the Living Reefs Foundation to support the health of Bermuda's reefs and improve coral cultivation and restoration. In their on-island hatchery, her team is developing scalable, reliable, and cost-effective methods for rearing new corals.
There are many, many challenges to growing corals. They're very, very complex. It's probably one of the hardest types of cultures I have ever had to do. But what we do is really concentrate our efforts on species that are important for the reef building aspect. And in so doing, you're actually protecting and always enhancing the coral reef ecosystem along the coast.
When corals from the hatchery are ready to be transplanted out, they're brought to the Foundation's coral gardens.
So the coral gardens are essentially an ocean-based nursery, and there they basically adapt to the natural environment, and then they will get to be a size where we can actually take those and plant them or cement them directly on the reef base of a damaged area.
Samia also envisions a future where coral restoration will be used to reinforce man-made structures, such as seawalls and connective roadways.
There's key infrastructure areas in Bermuda that could benefit from a more enhanced coral barrier. So this is where we have to prioritize. Is it more cost-effective to actually build a man-made barrier that will actually erode gradually every year, and that has to be replaced every 4 or 5 years? Or is it more cost-effective to invest into adding corals and restoring the coral that is there, and that will actually, instead of eroding, it will actually build and strengthen and become a sufficient coastal barrier? There's a ton of work to be done because, you know, we're really only touching the tip of the iceberg here.
Working at the edge of science and living at the edge of the ocean, researchers in Bermuda recognize the island's symbiotic relationship with its coral reefs and know all too well the need to adapt to the changing seas that surround them. Though sailors of old once avoided these treacherous waters, scientists today explore them for local lessons that could impact resilience globally.
We used to be this place where there were all these shipwrecks, right? And you had to be careful, but people wanted to come because it was a stopover place. And so we build these lighthouses, right? And we're this beacon, and here we are still in the center of the Atlantic Ocean, serving as a hope spot where we have healthy reefs that potentially might do really okay as climate change occurs. And as you make these choices about how are we going to respond to this sea level rise, we're having that conversation and looking at it directly and thinking about, we're going to be dealing with climate change. Okay, let's move beyond that. What can we do? How can we do this constructively?
You know, the motivation to fix things it's never been stronger and more current. And you know, when you're from here or when you work here, it's small. And for us, these are very local, very intimate problems, very intimate questions, but they're also things that it's all within the context of this is a place we love and enjoy and want to nurture. Bermuda can be referred to and have influence way beyond what you might imagine because that local knowledge, that local thing matters.
The far north. A storied place of daring exploration and untamed wilderness. But the high Arctic is also a place of rapid change.
The temperature in the Arctic is rising at a faster rate than the rest of the world.
Up here we see the changes most. The glacier fronts are literally disappearing in front of our eyes here. It goes very fast.
These changes are taking place at a time when modern science doesn't have a full understanding of how Arctic ecosystems work during all times of the year.
The polar night, that's defined as the period when the sun is below the horizon 24 hours a day. The length of the polar night varies according to latitude. At the pole, it lasts for 185 days. So at the pole, there's only one night and one day. At the Arctic Circle, it lasts for 1 day, and then there's everything in between.
It's basically dark 24/7. And so that has a huge impact on the fjord ecosystem. If there's no light, then there's no primary production.
There are algae in the ocean that are phytoplankton that photosynthesize to create energy, and all other organisms are reliant on that energy.
During the polar night, when the base of the food web is basically cut out, for decades, it was just kind of assumed that everything else stops. There's no food.
So this period, when it's dark, had remained completely unsampled, unstudied for many, many years.
Targeted research into polar night ecology didn't begin until 2009, after an accidental discovery made scientists realize this wasn't a dormant period in the ocean after all.
It came as a massive surprise.
And the more you look into it, the more you find that there's actually high activity during the polar night.
It's an important piece of the overall ecology of the ecosystem to understand, to tie it in with what's going on in the summer.
Looking at the seasonal patterns in the polar regions is a huge knowledge gap. So filling that in is important for that very base level fundamental understanding of how does the Earth work. And then the second layer is that the Arctic is very rapidly changing. We have warming water, receding sea ice, melting glaciers, things like that happening. So understanding the consequences of that change is a major question for the scientific community right now.
What tiny animals are active in the ocean during the polar night? And how are they able to survive without their main food source? January, a time when the northernmost latitudes are wrapped in perpetual darkness.
So we are in what we call the high Arctic. It's 79 degrees north. It's the northernmost settlements in the world.
Here the polar night lasts for approximately 4 months.
It's like you're tucked into a blanket of darkness. It's quite spectacular.
When the solar light becomes dimmer, then the lunar light becomes much more important, the stars, the aurora. The light climate simply changes quite a lot. I think the polar night is the most beautiful time of year.
We are in Ny-Ålesund, Svalbard. Svalbard is an archipelago halfway between mainland Norway and the North Pole.
The small Norwegian community of Ny-Ålesund is home to the world's northernmost year-round research station. Ny-Ålesund has a storied history. Whalers were the first in the area, followed by coal miners more than 100 years ago.
And it started in the early 1900s with the Kings Bay Coal Company.
Given its close proximity to the North Pole, Ny-Ålesund has also served as an expedition base. Famous Norwegian polar explorer Roald Amundsen and his team departed from here when, in 1926, they became the first to fly over the North Pole in an airship. In later years, the coal mines were shut down, and the community transitioned to a research base.
Because there was a big accident in 1962, and that was the end of the mining period. But as Ny-Ålesund had a very good infrastructure, it was in a very good position here at this peninsula to use it for research.
On location year-round since 1968, today the Norwegian Polar Institute, or NPI for short, implements the research strategy on site, which focuses on 4 flagship disciplines.
It's atmosphere, terrestrial ecosystems, marine biology and oceanography, and glaciology.
Kings Bay, meanwhile, still owns Ny-Ålesund and maintains all the infrastructure.
Kings Bay is basically the facilitator for the station. We organize transportation, we provide logistics solutions for all the institutions.
10 institutions, run by 11 countries, have a permanent or semi-permanent presence in Ny-Ålesund. Despite its remote location, the community not only boasts state-of-the-art research facilities, but also a lot of creature comforts.
The food is, beyond everything, and it's a lot of treats that we have up here. You can feel quite at home, I think, even if you're here for a longer time. You can have dogs, there's a gym, there's a sauna, there's a jacuzzi. So it's very up-to-date living-wise.
It's a great place to come to. It's very well set up.
Dr. Kirsten Meyer-Kaiser is based at the Woods Hole Oceanographic Institution, or WHOI, in Massachusetts.
The United States does not have a research station here. But nevertheless, we came here because it is such a logistically easy place to do research in the polar night and in the high Arctic because of the support from NPI and from Kings Bay.
The Norwegian Polar Institute hosts scientists from countries that do not have an institution from their own country to represent them.
The buybacks, you gave 100% for it too?
I did.
Kirsten and her PhD student, Karis Schrag, are studying some of the tiniest animals that are active during the polar night.
Our specific interest is in the early life history stages of all of the organisms that are living on the sea floor that do not have a backbone.
To find out what larvae are present this time of year, the researchers brave the Arctic cold to collect plankton samples in Kongsfjorden, the local fjord.
So to understand the larvae, we are towing nets behind a small boat, and the net has a mesh of 150 microns, which is incredibly fine, almost like a t-shirt. You're letting water through, but most animals will be caught in it. And with that, we can find really small larvae. So we take those up from the net, and in the lab, we sort through them all.
Plankton are things that drift around in the water column and have no power to swim against the current. So these basically come in a couple of types. You think of phytoplankton, which are algae. They use sunlight to make food. Zooplankton are animal-like plankton, and these are animals that I'm looking at. So I study things that only live in the water for part of their life cycle. These are called meroplankton, in contrast to holoplankton, which spend their whole life in the water column. I am sorting out all of the things that are the meroplankton, the larvae that I'm interested in.
Larvae are small enough that most of them you can't see with the naked eye, so you have to have the microscope.
Prior to preserving specimens in ethanol, Karis films and photographs the larvae.
Because as soon as you preserve them in ethanol, they're going to get contorted, they're going to shrink. So having that live photo before you preserve them or do anything else with them is really, really helpful to identify them later.
Larvae look very different from their adult counterparts, and many larval forms have yet to be identified. DNA analysis of the preserved specimens helps to determine the species, which can then be matched to the known adults.
Most of the organisms in Kongsfjorden are on genetics databases online. There's been extensive studies in Kongsfjorden.
The scientists are also trying to find out if the larvae are capable of eating this time of year.
Larvae can rely on yolk from their mothers for food. Like mom's packed you a lunch and you're good to go. Or you can get kicked out the front door with no packed lunch and have to find food on your own. And I was finding those types of larvae in the middle of the polar night in 2020, and I was really confused because there's no sunlight, so there's no algae for them to be eating. So how in the world do they survive?
Maybe they're not feeding at all. Maybe they're just kind of like holding on, white knuckling it, until lunchtime when the spring bloom arrives.
The spring bloom occurs when the light returns and phytoplankton can grow again. This fuels an explosion of activity from the bottom of the food chain up.
Many organisms time their reproduction to this burst of food. That way that their larvae get the best chance of having enough food to grow up enough and settle to the seafloor.
To test if the different types of larvae can eat, Kirsten provided them with phytoplankton.
I actually bought feed from an aquaculture company. This is what you can give oysters if you're culturing them.
The bodies of the larvae are clear, making it easy to tell if they've eaten.
If the gut was clear before we put them in with phytoplankton and it was green after the phytoplankton, that means they can eat.
The scientists discovered that one of their 2 test subjects was able to eat. But what might these larvae be eating in the wild, in the absence of phytoplankton this time of year?
And so for this, I've planned an isotope experiment. They might be eating bacteria. Bacteria can continue to exist in the water column. There's also dissolved organic matter in the water column. This is just like organic molecules. Amino acids are one example.
To test this theory, the team provided different sets of larvae with isotopically labeled amino acids and bacteria. If the larvae ate either, follow-up lab tests will be able to pick up on those traceable isotopes.
So doing those lab experiments, it's not a perfect indicator of what's happening in the wild, but it can give us the first step in trying to figure this out.
The researchers also want to find out if larvae are able to settle on the seafloor this time of year to begin their adult life. To do so, they need to undergo an energetically costly metamorphosis, which is similar to how a caterpillar transforms into a butterfly.
They completely change their body plan. They look like a pile of goo for a second, and then they look like the adult.
Some larvae use chemical cues to find a good place to settle, often near adults of the same species.
So for the settlement experiment, we're offering them kelp as a cue that we have pulled from the dock. The organisms that we're working with, we found them either attached to kelp or crawling on kelp as adults, and so we know that that would be a reasonable settlement location for them. We see a lot of competition as one of the main factors influencing mortality, especially during the early settlement period. And so by having your larvae survive through this harsh period of the polar night and settle before everybody else comes and spawns in the spring, maybe lets them grow big enough to give them a chance at outcompeting their neighbors when they get to the seafloor.
Several of the organisms decided to settle as part of the experiment. Studying settlement in the wild is much more challenging,
because we don't know what's happening when we're not there.
To monitor a settlement surface in the fjord, Kirsten worked closely with the engineers at Hui to invent a camera system that can record settlement in real time.
I call it CATAIN, which is an acronym, stands for Camera to Analyze Invertebrates. But what it really photographs is settlers. And that's actually why it's called CATAIN, because when I asked my husband, what should I name a camera system that photographs settlers, his answer was Catan. So we wanted to come up with something that was similar to the name of that board game. It's a camera system that photographs its own end cap. And you can see there's a macro lens and this little machine vision camera focused on the end cap, and then, all of the hardware and the batteries and everything. This is the brains of the camera. We've got a Raspberry Pi computer and we have a Sleepy Pi, which allows you to put the computer to sleep.
This will save battery power during months of deployment in near freezing waters.
So the only thing pulling power constantly is the clock. And when it reaches the time that it knows it's supposed to have a photo again, then it wakes itself up. Under this electrical tape here, there's actually a string of LED lights. The lights had to be on the outside so that it could flash through the end cap. It kind of functions like a ring light. Our settlement surface is vertical, so organisms are gonna settle on there, and then the camera is facing out, and it's gonna photograph the organisms from underneath. Using this, we are able to deploy the camera for long periods. I have it programmed to record an image every 24 hours. The reason that we want to do every 24 hours is because there's a lot of things that settle down to the sea floor but then end up dying within that first really short period. So most researchers actually study recruitment, which is so poorly defined. It's basically an operational definition. Recruitment is surviving until the researcher comes back to count you. Prior to us coming up with this camera system, it was really only possible to study settlement in environments where a researcher could be present every day, because you would put out panels and pull them back up 24 hours later, to see those first arrivals. Whereas with this, we can actually get a photographic record of everybody who was there without having to stay up here, all year. So I'm actually really excited about deploying this.
After years of planning and field trials back at home, the time has come to deploy CATAIN in Kongsfjorden.
To get it all set up, we had to create a heavy box for it to actually sit on the seafloor and not be jostled around by waves or whisked away.
We deployed this camera system at 15 meters deep, close to the old pier.
For hard bottom organisms, the highest abundance and the highest diversity is generally around 15 meters in Kongsfjorden. We marked a lot of GPS locations to make sure we know exactly where it is. We're gonna have to send divers down to attach a rope to it to bring it back up. When we finally got it to the sea floor, we were really excited because it's been a really long time coming.
We're gonna get so much data that was never before possible to obtain. I am so excited about this camera system.
How close we are to the German thing? Or are we okay?
While Catane will gather information about organisms that settle and live on hard bottom surfaces, the researchers also wanted to learn about species living in mud. To do so, they collected samples at 5 stations, ranging between 5 to 30 meters in depth.
So we've been sending a sediment grab to the seafloor off the back of the boat. It scoops up the first couple centimeters of sediment, brings it back up to the boat, and then back in the lab, we sieve through it at 2 different levels. One is 500 microns and one is 150 microns. And then we're left with a sample that is some sediment, but mostly organisms. And we'll take that back to the lab at Woods Hole and sort through them under the microscope and identify the species. We're mostly looking for things like clams and snails, but essentially we're trying to understand if the distribution of juveniles matches the distribution of adults.
In Arctic fjords, ice scour from sea ice or icebergs calving off the glaciers can scrape up the seafloor.
It's like a meteor landing on Earth. If you're a worm in your happy little tube in the mud and an iceberg comes by, you're not surviving that.
Past research has shown that the diversity of adult invertebrates that live on the seafloor increases as it gets deeper, and ice scour occurs less frequently.
Karis's question is, at what point in the life history does that gradient get set up? The hypothesis is that the larvae settle uniformly in any environment where they can survive. The temperature is right, the salinity is right, there's food for them, etc. And then the gradient in the adults happens because you have those shallow ones get scraped away. And also the top layer on top of all of that is the climate change. Going from a high sea ice cover in the fjord to now we've got open water pretty much all year round, that's probably indicating less ice scour, but the glacier is also melting, so then the icebergs calving off are more likely to impact the seafloor. And so which one of those is more important? Are we going to see more ice effect, less ice effect?
Long-term data collected in Ny-Ålesund is crucial to understanding our changing climate.
For example, on glaciers, there has been a study on the ice thickness between 1936 and 2010. The scientists saw that the thickness was reduced by 25 meters within the time span. So that is a very drastic reduction in the coverage of glaciers.
The last winter that really had sea ice here on the west coast of Svalbard, I think it was the winter 2004-2005.
These increased water temperatures are caused by a rise of greenhouse gases in the atmosphere. The Norwegian Institute for Air Research, in partnership with NPI and others, has been continuously taking measurements at the Zeppelin Air Observatory on the mountain above Ny-Ålesund.
We started the greenhouse gas measurements here in the 80s. First it was like CO2 and methane together with hydrocarbons, and then later we got the CFCs and CFC replacement compounds. If you measure greenhouse gases down on the continent, you will see a lot of fluctuations because you have a lot of emissions very close by. Up here you don't have these big emissions, so what you measure is what you call the atmospheric background. It's a good place to see how the atmosphere changes over time and how the greenhouse gases build up in the atmosphere.
The Zeppelin Air Observatory is part of a global network of stations that all take long-term measurements.
You need this big network of stations to get a really good global average to say when you look at the trends and how much it increases. Trends tell us that greenhouse gases like methane and CO2, it's not slowing down and it's increasing every year.
Knowing these changes are occurring adds a level of urgency to the research conducted during the polar night.
It's really important that we kind of play catch up and try to really get an understanding of the overall ecosystem, the simple basic biology of what's going on here, so that we can better understand how it's changing.
If you understand the fundamental process and the mechanisms by which things happen, then you can make better predictions of how is this going to look in the future.
It's one of the few sort of wildernesses remaining on the planet. It's like a natural wonder to be able to see this region, and I can only hope that my children and grandchildren will be able to experience some of what I have experienced, and in order for them to do that, we have to make sure that we take care of our planet.